2, 1. What is the limit?
1.
Very good. The second one, from which function?
-1.
Very good. And the limit is?
-1.
Good. So now I can conclude.
The limit doesn't exist.
Very good. Thank you very much. So I should have said that from the very beginning. This is 0 over 0, right? So I cannot draw any conclusion. So I have to go and separate, simplify, determine the limit from the left, determine the limit from the right. And it happens that the left-hand side, left of 2 is 1, right of 2 is -1. They're not the same. So it's D and E. Good. Anything else? So please remember this. Okay, next problem. What would you like to work on?
Could we do 5F?
Yes. C, D, E, F. Very good. So this is limit as x approaches infinity from the square root of x squared minus 9 over 2x minus 6. Good. How do we start?
Would we start by simplifying the numerator with it just being x? Never.
So what do we do? So first of all, it's infinity over infinity in an indeterminate case, so I can't conclude anything. So I have to start slowly, right? So this is limit as x approaches infinity. What do we do?
What I ended up doing was I tried to put everything underneath the same radical by squaring the numerator and then including that underneath the radical, or squaring the denominator, including that underneath the radical.
It's because my lovely students do not look at the notes. When they look at the notes, they will see. Anyone else?
Try and factor out x.
Say it again.
We try and factor out x's from each side.
Yeah, so let's start with the numerator. What do I do? What is the degree under the square root?
We'll do x squared.
So I have to factor out x squared. What is left in front? Yes?
And then 1 minus 9 over x squared.
1 over 9 over x squared. Very good. And the denominator, what is the degree?
I'll take out x.
Very good.
And we'll have 2 minus 6 over x.
Perfect so far. Now I have to analyze this and I have to write a note. The square root of x squared equals since x approaches infinity. And without this note, I cannot give full credit. So what do I write here? That's how my marker.
Or negative x.
That's how my markers are getting dry out. They dry out because I'm waiting for my students to say something. X indeed. Not needed. That's why I already wrote it's x approaches infinity. It should be the absolute value, but since I wrote x approaches infinity, it's x. Also, I will have to write this in case x approaches negative infinity. But this is not now. This is not our situation. Not here. This one is the correct one for here. I circle my answer so you know, or my equal symbol so you know I'm continuing. So then I have limit as x approaches infinity. I have to write the square root of x squared and the square root of 1 minus 9 over x squared divided by x and 2 minus 6 over x. I wrote my note. That's why this changed it into x. Equal symbol. And now what? Say it again.
Cancel x with x. And,
That's it. And now I can drop the limit operator because I'm applying it to this function. What do I get?
It's going to be 1 over 2.
Good. I have to write y equals 1/2 horizontal asymptote at infinity only. This is the entire correct answer, not just 1/2. Good. Anything else you would like to go back to? Other questions? Anything? Anything else? Okay, number 9. So we have f of x equals x minus 1 divided by x squared minus 3x plus 2. So what do we do here?
Factor the bottom.
Very good, awesome. That's always the case. Yes. How do I factor a denominator?
X minus 1, x minus 2.
Very good. I have to write that x does not equal 1 and it does not equal 2. Only then I'm allowed to do this. And I will write 1 over x minus 2. X equals 2. Vertical asymptote. And I will find the limits. But x equals 1. What is x equals 1 in this case?
Would it be a hole in the graph?
Thank you very much. Excellent. Thank you. Okay. And the hole will be, when you plug in 1 here, 1 minus 2, negative 1. So 1 comma negative 1 will be the hole. But for the vertical asymptote, I have to find the limit as x approaches 2 from the left of 1 over x minus 2, and the limit as x approaches 2 from the right of 1 over x minus 2. So what are these answers? Anyone? 2 from the left.
Undefined.
No. We can never write a limit that a limit is undefined. We can never write that. We can write a
So
number.
which of them, 1 over 0?
We can write a number. We can write infinity. We can write negative infinity, or we can write dne. These are the only options for a limit.
dne.
The limit from the left of 2.
Does not exist.
The limit from the left of 2, I imagine that I plug in 1.9, and this is negative infinity. It's a vertical asymptote. The limits have to be infinity and negative infinity. We know that. If it's a vertical asymptote, the limits have to be infinity or negative infinity on both sides. Most probably, it's a rational function. It cannot be a dne. Good. And what about the other one?
Infinity.
Very good. The limit from either side will be a dne. But this is not what I'm looking for. I need to determine the limits left and right. And for the horizontal asymptote, I have to determine the limit as x approaches infinity from 1 over x minus 2. And the symbol, it doesn't mean anything. So negative and positive infinity will not make any difference. What is the answer?
Zero.
Very good. I have to write y equals 0, horizontal asymptote. I don't have to write at infinity because it's at both for sure. Any questions?
For that, could we just write plus minus infinity in the limit equation? Or no?
No, we can't do that. I was just lazy. I was being lazy. Anything else? Because I would like to talk about the test for a couple of minutes.
So So for this, would you want us to write the limit as y approaches infinity of 1 over x minus 2 and the limit of y approaches
No, I'm
negative
fine if you
infinity
just
of
put it
minus
in
2?
parentheses like that. It's okay.
Gotcha.
Yeah. Um, I don't see anything else that the intermediate value theorem is just a polynomial function, and the other limits, anything else you would like to look at, or are you okay?
I think we're good.
Okay, so I'm going to stop here and do